Hello everyone, welcome back to MGF1106. So in the previous video, we already understood what a simple statement, what compound statement is. We learned how to use connectives to combine a simple statement to create a compound statement. Now, in order to understand and examine the logic behind a compound statement, there's a way we can do that. We can set up a table. We call that the true table, true and false table, for compound statement, and for all statement and also for AND statement. Then in this chapter we're gonna talk about that, and let's see. I can show you how to create this true and false statement, true and false table for those statements. Okay, so let's get started. So section 3.3. Okay, true table for negation, conjunction, and disjunction. Negation, conjunction, and disjunction. So we already know that negation means we do the opposite meaning of a statement. Conjunction we do and disjunction we do or. Compound statement we have two more statements. We have if and then, and we have if and only if, but we're going to talk about that in section 3.4. Okay, so let's set up the truth table for the negation first. Okay, so on the first part, negation. Okay, now think about that. In order to negate a simple statement, a simple statement either true or false. So in order to negate the true, it will be false. And in order to negate false, there will be true. So this table, true and false table, for negation will be very simple. Okay, it will be very simple. So given a statement P statement. So in order to create a true table for P statement, we know the negation of P will be tilde P, right? We already know that. So P, let me create the table over here. This is very simple table. Okay. Given the P statement, then negation of P is notated is that tilde P. So we already learned this in previous video. So the two table can be created like this. Okay. So I have need another one. Okay. Okay. So over here we have. Okay. So tilde P I put over here. So the statement is either true or false. So it could be true or false. Then the negation of true will be false. Okay, and the negation of false will be true. So let me use a different color over here so that you know that that's what we already have. We already make it opposite. So true will be false and false will be true. Okay, so that's the true table for the negation. Okay, very simple. Okay, because that we have, if we have only one statement, then one simple statement, then this could be either true or false only. There's nothing else. Now let's talk about. I think I'm mess up this something over here. I changed a little. 3.2. Okay. How about we set up the true table for conjunction? Okay, how about true table for conjunction? So second Roman conjunction. So we know the conjunction is not simple statement. The conjunction is the combine between two simple statement. So this conjunction statement is actually the compound statement. We already know that, and and compound statement is a combine of two simple statements. Okay, two simple statements. So let's see how many arrangement we have for 2 and 4 when we have two simple statements. So given P and Q statement. So there are two simple statements to create a compound statement. Then how many arrangement will we have? So we will have totally 4 arrangement. So we have so we have 4 arrangement. Okay, because the formula in order to get 4 is that because it's a 2 statement, so we put base 2 raised to the second power. Because there's 2 statement over here, so we raise to the second power. The base is always 2. Okay, the base is always 2. So we will have 4. Okay. Now I'm going to go ahead and draw the truth table for conjunction statement right here. So this is conjunction is AND statement. It's an AND statement. Okay. All right. Let's see. I can go ahead and create the table. I already have the table here. Okay. You don't need that, but I already create the table so that I don't have to redraw every time I need it. So I already have a table over here. So we have P and Q. So we have statement P and Q here. So we have P. Okay, let's use different color here. So we have P here, and we have statement Q here, and we have AND statement. So you have P intersect Q. There you go. Okay. So we have totally 4 arrangement. Because each of simple statement we have 2, so we might have something with 2 and 2. Okay, so it could be let's use different color. Could be it could be 2 and 2. Okay, then it could be 2 and 4. Okay, then 4 and 2. Then finally 4 and 4. Okay, so 1 arrangement, 2 arrangement, 3 and 4. So we have 4 arrangement, 4 row. I'm sorry, 4 row, 4 arrangement. Now, in order to inspect the 2 and 4 of the conjunction statement and statement, I want you to memorize. You don't have to memorize this table, but I want you to memorize this example. And this example here, it helps you to get a true table for conjunction without memorize the table. Okay, so the example I give you is this. Try to memorize this. Okay, a company. Okay, company. Okay. I hate this. I don't know why it's not working. Sometimes working, isn't it? Sometimes not. Company. Okay. Company. Company. Promise to a customer that it will deliver TV and laptop on Saturday. on this deliver laptop. I don't know. I cannot erase. Deliver this Saturday. Okay, this Saturday. Okay. So you see that over here, deliver TV and laptop is the conjunction. So the company promised to customer that we deliver both of them on Saturday. So it means if we deliver only one of them, then the promise is broken, right? If we deliver only laptop on this Saturday or deliver only TV on this Saturday, so the promise is broken. If it does not deliver any TV or laptop this Saturday, then of course it's broken. It could be that if the promise is broken, then it will be false. So if it deliver both of them, okay. This is right over here is the first statement right here. It's the P statement right over here. So this is the P statement right here. Okay. Then it's a Q statement right here. So if we can deliver both of them, then the promise is kept. Okay. Okay. If the promise kept, then it will be true. Okay. It will be true. Okay. Then if it cannot deliver one of this, then it will be false, right? Because the promise is broken. So this is a problem. The promise is broken. Same thing. The promise will be broken here. And of course, if it does not deliver any TV or laptop, the promise is broken terribly, right? Okay. So you see that by memorize this example here, I can create the conjunction statement, conjunction truth table for conjunction easily without memorizing. Okay, you don't need to memorize it. There are some of the students just memorize because when they do when they create a truth table for the more complicated compound statement. But I mean, you don't need to memorize it to create a truth table for more complicated compound statement. You just memorize the example I give you over here. Then you should create your truth table for conjunction or for end statement easily. Okay, good. Now, how about the truth table for a disjunction? Okay, how about truth table for disjunction? Okay, number 3. Disjunction. So disjunction is or statement. Okay, so I have a table like this. Okay. All right, so you have P and Q. Again, we have two statements, P and Q. So we have P here, Q here. Then we have P, disjunction, Q. Okay. And again, we have only for arrangement. So we will have two, for two, for two. Okay. For two. And for 4. Okay. So in order to get 2 and 4 column, 2 and 4 for this column, you memorize this formula. Okay. Again, a company hires an employee candidate. Okay, if that candidate has bachelor degree, 4-year bachelor degree. Okay. Or has at least 6 years experience. Okay. So we have two statements over P and Q. So P is right over here. P is this 4-year. P is 4-year 4-year bachelor degree. That's P right there. And or 6-year experience. So this is Q right here, and this is P right here. Okay. Okay. So if the candidate has a 4-year bachelor degree or 6-year experience, so if this word is true, then of course over here could be true. Over here could be true. Okay, it'll be true because they need only one one condition: 4-year bachelor degree or 6-year experience. But if it is satisfied, if the candidate is satisfied both of them, then it will be true. Okay. I'm gonna add a little bit over here. I'm gonna add a little so that it's easier for you to understand. Company promise to hire. Okay, promise to hire. Okay. So if the candidate has 4-year bachelor degree and 6-year experience, so the company hire him. So the promise is not broken. But if he even has, the candidate has only one of them, so if he has 4-year bachelor degree, then it's still high because then this is all. So this is true also. It's true also. And what if he doesn't have a 6-year experience? He has only 4 years. Then of course it's still high. It's true. Okay. And however, if it is like if the candidate doesn't have a 4-year college nor a 6-year experience, then the company cannot keep the promise. Because if it can only keep the promise if he has one of the satisfaction over here, one of the condition here. But because the candidate cannot because the candidate doesn't have 4-year bachelor degree nor 6-year experience, so the company cannot promise. Okay, the promise is broken, so he could be far. Okay, see that I can create the truth table for disjunction and conjunction easily based on the example I give you right here. Okay, you don't need to memorize. If you memorize, that's fine, but you don't have to. Okay, because sometimes in your MATLAB homework they change the order, then you probably confused. Okay, if you memorize this example, then no matter what the order they change for the arrangement over here, you still able to get the correct true and false column for disjunction and conjunction. Okay. All right. Now I'm gonna give you the first example. Okay. Example number 1 over here. Okay. Okay, let's construct the truth table for very simple symbolic statement right here. So construct. Okay. Truth table. Okay, for the symbolic statement I have over here is P. Okay, and this is a disjunction with negating P. All right, so let's see how we construct the truth table for this. So we need the truth table, huh? Okay, answer. Because there's only two statements over here, so probably the truth table is not really complicated. But I'm gonna go ahead again. I'm gonna go ahead and load my truth table. We probably don't need all the empty column and row over here because this should be very simple. So I have two. Again, I will have P. Okay, we have Q. Then we have negation of P. Hold on. I think it has something P. Oh, so negation of Q. I think I messed up over here. I'm sorry. So Q. So this is Q. Okay. Then I have negation of Q. Negation of Q. Then finally I have P union negation of Q. Okay. Again, we have only two statements, so we have only four arrangement. So we will have so we have two, four, two, and four. So most of the time, this the first two columns over here is the same for all of them. Then we try to negate the Q over here. So if we negate the Q, so we will end up with 2, then become 4. Okay, 4 become 2. Okay, then 2 become 4, and 4 become 2. Now we're gonna go ahead. Okay, take the union, take the OR statement between this. Okay, again, try to think about the example I give you. This is OR, so the example is the company promised to hire, right, a candidate if he satisfy one of the case. So true for, okay, so it's true for, so he satisfied the first one, he does not satisfy the second one, the second condition. So this is give you true. So this is give you true. Okay, so this will give you true because okay, this is not a good color at all. But anyway, okay, okay. I'm gonna go ahead and use different color. So this is give you 2 and 4 give you 2. Okay, 2 and 2, of course, if satisfy 2 conditions, 2 requirements, so of course it's true. But 4 and 4, it doesn't satisfy any requirement, so this will give you 4. And 4 and 2, he satisfy a 5-year experience, 6-year experience, but he doesn't have actually degree, so it's still true. There you go. See that? You don't need to memorize it. You still can get the disjunction for truth table easily. Okay, but this one is pretty simple. Let me see. I can give you something else. Oh, how about this? How about this? Example number 2. Again, construct truth table for. Okay, how about this? Negate of disjunction P Q. Okay, let's see how we do that. Okay, again we need the table. Let's do the table. Upload the table. Okay. All right. So again, we're gonna have P over here, P here, we have Q here. Then we have P conjunction, disjunction. I'm sorry, Q. Then we finally we have the negate. Let's see if I can make it a little bit bigger. No, I cannot. Let's see. Oops. I'm gonna make it bigger. There you go. Let's see if we can make it bigger a little bit. Yeah, I can. There's no more space over here. That's okay. So we need the negation. Okay, I'm gonna write over here because it has more space. Negation of P union Q. Okay. Okay. All right. So we're gonna have we have two statements. So we have true true, true false, false true, and false false. All right. So this is still union. So this is still disjunction. So think about a company hiring employee candidate. So he satisfied two requirements. So this should be true. He satisfied only one of the requirement is still true. This is still true. Then it will be false. Then you negate this, so that will give you the final answer. It will be false, 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 true. Yeah, easy, huh? Very easy. All right. Yeah. All right. How about the next one? Let's do something more complicated. Okay. Let's see. Example number 3. Okay. Construct true table. 4. Okay. We have tilde P, disjunction Q, conjunction tilde Q. Okay. All right, let's load the table. Okay, let's make it a little big because we need this is more complicated. Okay, so again we're gonna have we have only two statements, two simple statements, so we have only 4 arrangements. Later on, I'm gonna give you the one with 3 arrangements. Hopefully, I have it. Trying to figure out with the 3 arrangement, and you will see. So you're gonna have P over here. Okay, you have P, Q, negate of P. Okay, then negate of P, disjunction Q, then negate of Q, then finally the whole thing. So I'm gonna put the whole thing as I'm gonna call this statement over here is statement A. Okay, so I have A. Okay, that's the final. All right, so let's put it in. Put all information in. So we're gonna have we have true, 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 false, false, true, false, false. So negation of P will be false, false, true, true. Then you do the disjunction, the union between this. So satisfy the first condition, so it's still true. It does not satisfy 2 requirements to become employee, so it will be false. This will be he satisfy both, it will be true. He satisfy one, it will be true. Now we do negation for this will be false, true, false, true, right? Negation of true is false, negation of false will be true. Then now we're gonna do conjunction between these 2 columns right here. So for conjunction, we think about a company promise, right, to deliver TV and laptop, right? So if he did not deliver one of that, then the promise broken. Okay, so you see that he failed to deliver one of them right here because this is false. So the promise broken. So finally, you will have false, He failed to deliver TV, so we 4. He failed to deliver laptop, so we 4. Okay, and he delivered both, so should be 2. Okay, see, very easy. No, nothing is really hard over here. Where's the 4, 4, 4, 2? Okay. All right. Now let's see. Let's see what if they give us the, instead of symbolic statement, they give us just sentence statement. So from the sentence statement, we create the symbolic statement. Then we create the truth table for that symbolic statement. Let's see, we can do that. Okay. Let's see. All right. Example number 4. Okay, so I have a statement like this. This is a compound statement, but it's written. Okay, it's written. It's not symbolic statement. Given statement. Okay. And the statement is, I study hard and ask the final. I study hard and ask the final. Okay, comma. Okay, or I fail the course. Or I fail the course. Now, if you notice this sentence statement right over here, okay, this written statement over here, they have 3 parts. So look like that this compound statement is combined by 3 simple statements. So we need to give them a letter represent for each simple statement. Then try to get the symbolic statement, and at the end we're gonna put that on the truth table. Okay. Okay. So answer. So the first statement is P. Okay, I study hard. Okay. Then the second statement is Q. I X the final. And the first statement is I fail the course. Okay. So let's see how we're gonna go create the symbolic statement. So look like there's the comma over here. So I mean this is the whole group right here. So I study hard and that's so could be and mean the conjunction. So P conjunction do conjunction with Q, or mean disjunction. Okay, disjunction with R. Okay, disjunction with R. Okay, so let's see how we're gonna create the truth table for this one, because now we have 3 statements. So last time we have only 2 statements, so we have 4 arrangement. So from here we have 3 statements, so we gotta put 2 raised to the 3rd. So we have 8 arrangement. Make sure you don't want to miss any arrangement here. Okay, so let's create the table. Okay, hopefully I have enough table here. I have enough row and column. Probably not. I think we can go ahead. 1, 2, 3, 4, 5, 6, 7, 8. Oh, so look like I missed another column, another row, not another column. So I'm gonna put P and Q up here. Okay. So I'm gonna put this one P. This is Q. This one R. Okay. Then this one P intersect Q. Okay. Then finally we're gonna have P intersect Q union R, so I'm going to call that is A, symbolic statement A. Okay. All right, so we have three cases, three symbol statement A arrangements. So the first one, we don't want to miss it. So the first one, I'm going to put true for all of them. So true. And then I'm going to put one of them to be false. So I'm going to put the last one false. So true, false. Then I put this one false, true, false, true. Then I put this one false, true. Then I put two false. So I put true, false. Okay. Then for true, false. Okay, then I move this one over here, and finally we have for true, and at the end we have true. Oh, for. Okay, for. Okay, there you go. All right, so we have totally 0, 1, 2, 3, 4, 5, 6, 7, 8 arrangement. Now we're gonna do P intersect. So it will be, this is the delivery promise example I give you. PQ, so true they deliver both. So it will be, this one will be true. This one will be true. Okay, then this one also be true because it deliver both. This failed because forgot to it broke the promise. It did not deliver the laptop. It did not deliver the TV, so this is 4. I did not deliver the laptop, it will be 4. Did not deliver the TV, it will be 4. Did not deliver both, so it will be 4. And it will be 4. Okay. Then now we're gonna go ahead do the union with this one. So this is company promised to hire candidate. So if the candidate has to satisfy 2 requirements, then he got hired, so that would be 2. Okay, so it would be 2. He satisfied only 1 condition, so it could be also 2. And this is also 2. This satisfies 1 condition, it could be 2. He does satisfy any conditions, it would be 4. And 4. And it would be 2. And he does not satisfy 2 conditions, so we cannot the promise broken, so it will be 4. So you're gonna end up with 2, 2, 2, 2, 4, 2, 4, 2, 4, 4. Yeah, that's what it is. Okay. See, you see how easy if we apply, we think about the example I gave you. If you don't think about the example I give you, then this example I mean right here, then this kind of tough. Okay, so this kind of trick it helps you to create the truth table for any compound statement. How much complicated it is, you can create a compound the truth table for that compound statement easily. Okay. All right, so I'm gonna stop the video over here. So next time we will be discussing the truth table for if and then statement and if and only if statement. Okay, I'll see you next time. Bye.